In this case, the first thing I do is I want to factor x cubed minus 8. And x cubed minus 8 is a difference of 2 cubes, so it's x minus 2 times x squared plus 2x plus 4. So I am going to decompose it into a over x minus 2, the linear factor, plus now it's a quadratic, so I need bx plus c over x squared plus 2x plus 4, and that's going to equal my original, which is 6x over x cubed minus 8. So I can rewrite this, getting a common denominator, a times x squared plus 2x plus 4 plus bx plus c times x minus 2 is 6x. So what I'm going to do here is I'm going to pick some x's that will help me solve for a, b, and c. The first one I'm going to do is I'm going to pick 2, because if I pick 2, 2 minus 2 is 0, and this goes away, and I can solve for a. So when I plug in 2, I have a times 2 squared plus 2 times 2 plus 4 plus b times 2 plus c times 2 minus 2, which goes to 0, equals 6 times 2. So I have 4 plus 4 plus 4, so it tells me 12a is 12, or a equals 1. So I know that. Now I have to figure out some other numbers. There's nothing else that I can put in here to get rid of the a, but it doesn't matter, I already know what a is. So I'll just pick some simple numbers that'll help for x to help me solve. So if I want to get rid of perhaps my b just to solve for c, I could let x equal 0. So I have a, which is 1, times 0 squared plus 2 times 0 plus 4 plus b times 0 plus c is 0 minus 2, which equals 6 times 0. So let's see, I have 4 here, plus negative 2c is 0, or 4 equals 2c, and c equals 2. I still need to find b, but it's pretty easy. I can just pick any number. I'm going to pick 3, but it doesn't really matter what you choose. So I have a is 1 times 3 squared plus 2 times 3 plus 4 plus b times 3 plus c, which is 2, times 3 minus 2 equals 6 times 3. So that becomes 1. That's why I pick 3. I have 9 plus 6 plus 4, which is 19 plus 3b plus 2 equals 18, or 3b is negative 3, so b is negative 1. So now I have my 3 values. I'm going to write my fractions, and I'm going to show my decomposition and solve. So my integral is the same as 1 over x minus 2 dx plus integral of negative x plus 2 over x squared plus 2x plus 4 dx. Well, this one's easy to solve. This one isn't so much. So we're going to do one more trick. We're going to add and subtract the same number and see what we get. So what I'm going to do is I'm going to subtract 3 here. So I get negative of x plus 1. And then I need to add a 3 over x squared plus 2x plus 4. But before I go over any further, I notice also here that I need to, maybe I can try to complete the square. So I'm going to look at x squared plus 2x. If I add 1 here, I subtract 1, it's plus 3. And I have x plus 1 squared plus 3. Maybe I can do something with that. So I'm going to rewrite this. This I already know is the natural log of x minus 2 plus, now I have negative x plus 1. If u is x squared plus 2x plus 4, du is 2x plus 2, which is 2 times x plus 1 dx. So I have the x plus 1, I need the 2, so it's, and I have a negative here, so it's negative 1/2, and then I have natural log of x squared plus 2x plus 4. And the last one I have is plus the integral of 3 over x plus 1 squared plus 3 dx. Well, this is just inverse tangent, so I have the natural log of x minus 2 minus 1/2 the natural log of x squared plus 2x plus 4, and then here, if I use inverse tangent, my a is radical 3, okay, and so my u is x plus 1, so I have plus radical 3 inverse tangent of x plus 1 over radical 3, and then plus c, and that's my final answer. If I look here, it's going to be, the 3 is on the outside, so it's really 3 times, and there's a 1 here, and then I have 1 over radical 3, and 3 times 1 over radical 3 equals radical 3, and that's how I got my radical 3 there.